All right, I'll show you how you do this. Okay, so, okay, cosine inverse of 4 over 5. What this is telling me is, or what it's asking me is like, this is what angle theta when I take the cosine of theta, I get 4 over 5. Okay? That's what inverse cosine. Okay, and the reason why this works, like, do you see how, like, if I do cosine of inverse cosine, right? This would just give me 4 over 5. Like, this is an angle such that when I take the cosine of it, I get 4 over 5. That's what it means. Inverses work the same way. Like, you remember if I have, like, 3 times 3 inverse? What is this? What is this, Bob? What if I do 3 times 3 inverse? What's that?
1.
Good. Because 3 inverse is the same thing as 1 over 3. And so when they multiply by each other, you get 3 over 3, which just gets 1. This is the cool thing about inverses. Inverses, they annihilate each other. This is like what Nick was asking about antimatter and matter. Like, if matter and antimatter get close to each other, it's just like they annihilate each other. It's the same thing with inverse functions. If you take the inverse function of a function, you get the argument back. But okay. All right, so this is what angle... when I take the cosine of theta, I get 4 over 5. How you start these ones, Bob, is you draw a triangle, okay? And I'm going to label this angle theta, okay? And what I know is that the cosine of theta is equal to 4 over 5. The reason I know that is because, again, if I did cosine of cosine inverse of 4 over 5, right? So yeah, this is actually cool. So cosine inverse of 4 or 5 is an angle theta, right? Inverse cosines give you angles, right? If I take the cosine of both sides, that tells me that 4 over 5 is equal to the cosine of theta. Do you see how, like, these annihilate? Oh, thank you. Someone's making me drink water again. Thank you, Ethan. Cheers. Okay. All right, so the cosine of theta equals 4 over 5. This is my triangle. Okay, what is cosine? What over what?
Cosine is... I'm not sure.
Okay, this is the whole SOHCAHTOA.
Oh.
Gotta remember this.
Adjacent over hypotenuse.
Good, this is adjacent over hypotenuse, okay? Which we know is equal to 4 over 5, okay? So on my triangle here, right? Where's the adjacent?
The adjacent is on the bottom.
Bottom, good. So this is going to be 4. Where's my hypotenuse?
The diagonal line.
Diagonal line. There, good. Okay. So this is my triangle, right? But then I want to know what the sine of that angle is, right? So this is my triangle, and I want to know what the sine of theta is, okay? Sine is what? What over what?
Opposite over hypotenuse.
Good. Cool. Which, let's see, what do I know? I don't know the opposite yet, right? But I do know the hypotenuse, right? What's the hypotenuse?
5.
Okay. Here we go. How do you think I'm going to find the opposite? What is it going to be?
Do I plug it into the... Oh, it's the Pythagorean triplet.
It's a triplet. Yes, yes. Do you see how everything is related, dude? This is a Pythagorean triple, right? This is 3, 4, 5. That's how I told. This is why, like, again, your teacher doesn't want you to, like, actually grade, like, hard things and whatnot. They want easy, nice numbers, right? You should always be looking for this in, like, homework and test questions. Is like, this needs to be easy to grade, right? So yes, we know that this side, right, is going to be 3 because that makes a 3, 4, 5, right? Cool. So right, the sine of this is then going to be 3 over 5, right? So yeah, this whole answer is just 3 over 5.
Oh, okay, I see.
See how that works? Dope, right?
Yeah.
That's pretty cool. Okay, let me show you something slightly harder, Bob, real quick. Let's say I want the sine of arctangent of 2. Do you know how to do this one?
No.
No? Okay. Well, let's try to think about it, right? what do I need to do first, right? I need to get this as an angle, right? What's the
It's on
process?
the quadrant 3.
Quadrant 3? No, not quite.
Quadrant 1.
It is quadrant 1. It could be quadrant 3, but I think tangent's defined in these quadrants, if I'm not mistaken. I forget. I forget if it's these ones or these ones. Arctangent is. The main thing is you wanna draw this, right, as a triangle, right? This is always, anytime you see like arc whatever, like draw your triangle first, and that'll help you out, okay? This is some angle, right, where tangent of that angle is equal to 2. What is tangent? Whatever what?
Opposite over adjacent.
Good. That's opposite over adjacent, right? So what am I going to draw on my triangle?
The opposite and the adjacent.
Good. What's the opposite going to be?
Vertical line.
Yeah, that's going to be what?
Um,
You see how this is tricky because you have just one number here and you're like, oh shit, what do I do?
2.
Good. That's going to be 2. What's the adjacent going to be?
1.
1. Yeah, this is the same thing as 2 over 1. That's what I wanted you to get across, okay? And then yes, if you needed to get the hypotenuse then, right? Then you got to do the Pythagorean theorem. You got to do 1 squared plus 2 squared equals c squared. So this ends up being the square root of 5, right? So then the sine is opposite over hypotenuse, right? So this is going to be equal to 2 over the square root of 5, which you can rationalize. Remember how to rationalize, right? This is going to be 2 square root of 5 over 5, right? And that's going to be your final answer.
Okay.
Does that make sense?
Yeah.
Cool. Awesome. Dope, dude.
Thank you.
You're welcome.